Hello Year 10, and I hope you're all well and happy and healthy. So what we're going to do today is we're starting another new unit. Now I have attached the rag sheet for this and we'll go through that in a second, but today's learning outcomes, there are 4. You'll notice that there are 3 that are common to both the higher and foundation paper, but 1 that is specifically for the higher paper. So we're looking at how objects accelerate, the forces that cause acceleration, and the effect of mass upon acceleration. We're also going to go through a couple of calculations just to make sure you're all tip top on that. You possibly will also need a calculator for this lesson. Okay, or just use your phone if you're doing it at home. So here is the rag sheet. Now, obviously the before column, that's today. Today is before. So just quickly, if you haven't done so, just print off that, and if you can, otherwise screenshot it and annotate. And what I want you to do is red, amber, green as to where you are. Red being, oh, I don't know anything. Amber, sort of know what they're talking about. Green, I'm absolutely awesome at this and I could do it now, the exam now, without any practice. That's our criteria. So I'm going to pause the slide and you can do that now. Brilliant. You'll also notice, sorry, really bad person here. The bottom 5 are for those doing triple only. Okay, so if you're in the triple groups, please make sure that you're looking at those as well. If you're not in the triple groups, don't panic. Okay. So the king of forces and acceleration and motion is Sir Isaac Newton. Here he is with his gorgeous long locks, looking lovely. So what we've got here is one of his first law, which talks all about the fact that an object will stay at rest or stay in motion unless it's acted upon by an unbalanced force. So in other words, if you're stationary or still, you're going to stay that way until something makes you move. Or if you're moving, and you're moving at the same speed, until another force acts on it, there will be no change in your speed. It doesn't really explain, though. He didn't really explain in this law why some things are harder to move than others. Okay, so think about this cartoon to start off with. Why is the large stone harder to move than the smaller stone? Just think about that for a second and think how you'd answer that question. Now, what we've got here is the fact that the large stone has more mass, and therefore is heavier than the smaller stone. So therefore it require more work or more force to move it. So the heavier something is to move, the harder it is to move. Okay. So here we go. This is Newton, still looking dashing, and his second law. So he's basically saying that if the acceleration of an object is directly proportional to the force acting on an object. So in other words, the more force used to move an object, the faster the object will move, which seems quite logical, doesn't it? So if the acceleration of an object is inversely proportional to the mass of the object, in other words, the larger the object the harder it is to move the object. So challenge. Look at these images, okay? How could this be written as an equation, and what would the units be? Pause the slide now and have a think about it. So, again, force equals mass times acceleration. Again, can be put straight into my lovely equation triangle. This is given to you on the equation sheet, so you don't need to learn it, but you do need to be able to rearrange it for the higher tier. So we've got, if the force is applied, blah, blah, blah. So Newton's second law. So there is this emphasis in the physics paper on the ability to state laws and apply laws. So one of the things they want you to do is be able to recall each of the laws. So if you haven't done so, you need to write them out, put them on some flashcards, post-it notes around your bedroom so that we can recall those really quickly and they're embedded. One of the things that we need to really ensure that we're doing is the fact that we are understanding the key terms. So I'm going to go through them so that you're familiar with them and that you can use them with confidence. I would suggest you make notes as you go on, just because this is really important information, and this will be the sort of thing that is going to come up. So what does the term proportional mean? So what they want you to know is that if you increase one, the other increases. So that can be on a graph either a straight or a curved line moving from the origin, moving up away from the origin. If it's directly proportional, it means that if you increase one by an amount, you always get a change of the same amount for the other variable. So you increase one variable by 1, and the second variable will always increase by the same amount, giving you a perfectly straight line. Again, moving up from the origin, the O, where the two lines intersect, away from the join in the axes. However, inversely proportional is basically the opposite. So if one increases, the other decreases. So what we see then is the line, the gradient, straight line, okay, not curved, but dropping away from the y-axis, dropping down to the x-axis, where almost zero, okay. And the symbol, which is drawn on the slide in blue, that symbol is proportional. So if we talk about that the resultant force is proportional to mass times acceleration, that we know that if you have a change, increase either mass or we increase acceleration, then we get a change, a proportional change in that resultant force. So let's look at an example so we can work through it together. So we're going to find the force acting on an object with a mass of 10 kilograms and an acceleration of 5 meters per second. So we've got the mass and then we've got the acceleration. So we do 10 times 5. Okay, and on here I've highlighted it. I've highlighted the 10, I've highlighted the 5. In the exam, it's really good to highlight the numbers in the exam, because sometimes when you're reading through and then going back and looking for them, you can't find them. Highlight away, go for it. Underline, do whatever you need to do, but it is really good skill to be able to pick out those numbers. So we've got 10 times 5, so my resultant force is 50. Nice and easy. Hopefully we could all do that. We're taking off our shoes and socks. So you get 1 mark for writing the equation, 1 mark for working, 1 mark for correct answer, and 1 mark for units. I'm going to keep coming back to this, but the physics paper is 40% maths. And a lot of that maths you can do without really trying, without even taking your shoes and socks off. It's simple maths, and they give you the equation sheet. So all you've got to do is try to apply them. Now a second worked example. This time the acceleration is a mass of 5. We're calculating the acceleration this time. It has a mass of 5 kilograms, and the resultant force is 100. So 100 goes at the top. We divide by 5. Okay, and hopefully, again, highlight to show that we know where we've got those numbers from. And we do 100 divided by 5 gives me 20 meters per second. All right. Now, it's meter per second squared, and that's really important because if they forget that little squared, then you won't get that mark. It is really key. When we mark and go through these in class, we go through the perfect model answer. But if any of you want to have a peruse through the AQA spec and the past papers and the mark schemes, you will see it says give credit to any evidence of. And if you've tried and even if you haven't got the right answer and you've tried a different method and it's a credible method of trying to work this out, they will give you the marks. So there is no value in leaving anything blank, okay? Give everything your best shot. So first of all, what I want you to do is pause the slide and answer these 5 questions for me. Thank you. Okay, so looking at the steps we remember, before we go through the answers, just check that you've done what you need to do. We're going to go through number 1. And the answer to number 1 is 35 newtons. Give yourself marks for each of the stages. Number 2, the answer is 2.1 newtons. Number 3, 20 meters per second squared. 50 meters per second squared. 5 kilograms. And 4.5. Oh, hang on. No, sorry. They're asking you to work out what acceleration is, which is 8.8 meters per second squared. Just as a reference, please make sure when you're measuring these things, make sure that you're thinking, does that unit sound right? Because if it said that what is the mass of the pram, and your answer came up with, I don't know, 500 kilograms, well, that would be half a ton. So that would be totally unlogical. So you need to make sure that they're within the realms of sensible common sense. Otherwise, people are just going to think numpty. Okay, they don't really want you to sort of pull numbers out of the air. They want you to realise that actually, if those numbers are too huge, you've done something wrong. Go back, look at your equation sheet. So, inertia. Now, I have said that this is for the high tier only, but I think it would be good for everybody just to get the concept of what inertia is and how we can apply this common sense to other areas. So what I want you to think about is inertial mass is the resistance to change. And lots of people, this could possibly be most simply described as that the inertia of an object is the force that is travelling at divided by its acceleration. And therefore, if something has more mass, it has more inertia. It's as simple as that. It's not anything more complicated. So therefore, if you want to push a bucket of sand, it is easier to push than pushing an elephant. Okay? And therefore, what they want you to do is you think about this in terms of Newton's second law of motion and apply that concept. Right. So, little bit of science joke for you because we don't get out very much. And lastly, key points from today's lesson. I suggest you pause these, write these down. Once you've finished, I suggest you go and do the SAM learning task that's associated with this so that you've got it under your belt. And obviously I will be uploading the grades as we go. All right then, thank you guys. Bye.